Question number 7 is asking us to solve a first-degree equation, and the problem with this equation is this equation has a lot of decimals in it, and me personally, even though in Math 1033 you're allowed to use a calculator, I think it's a good idea to get rid of the decimals. So let's go ahead and look at my paper and look at the equation we have. All right, there's your equation. 0.3x plus 0.7 times the quantity 4 minus 5x equals the opposite of 0.8x. This is one term, the 0.3x. 0.7 times the quantity 4 minus 5x is another term. And the opposite of 0.8x is another term. Each one of those terms, if we multiplied by 10, would move the decimal appropriately to turn that into a whole number and get rid of the decimal. So I'm going to multiply the first term by 10, I'm going to multiply the second term by 10, and I'm going to multiply the third term by 10. Be careful because this is an equation, so remember what you do to one part of that equation, what you do to one side of it, basically what you do to all the terms on the left, you have to do to all the terms on the right. 10 times 0.3 would become 3, and then of course we have our x, plus 10 times 0.7 becomes 7. In parens we have 4 minus 5x. Now a mistake sometimes that students make is they multiply everything inside here by 10 also. What you have to remember is this is one term, so you only multiplied by 10 one time. On the next line, when I distribute the 7, it will take care of what's inside the parens. 10 times a negative 0.8x becomes a negative, or the opposite of 8x. Now it's a pretty traditional and pretty easy equation to work with. We have a 3x. We distribute the 7, which gives me 28 minus 35x. I'll preach to you like I do my own students. Watch your signs. Be so careful when you're distributing and when you're collecting like terms. It's one of the main problems in algebra is people that drop their signs or mess them up. On the left-hand side of my equation, when I collect like terms, the 3x minus 35x becomes the opposite of 32x, plus 28 is equal to the opposite of 8x. Now, what we need to do at this point is get our variables on one side and the numbers on the other. Traditionally, variables seem to be taken to the left and numbers to the right, but what I try to look for is the quickest way to get them on the same side, and in this case that would be by adding 32x to both sides of the equation. So that's what I'm going to do. By adding 32x to both sides of the equation, the left-hand side of my equation, I just have the number 28. I have my equal sign. And on the right-hand side of my equation, negative 8x plus 32x is going to give me 24x. X is being multiplied by 24, so to get it alone, to get the x alone, we need to undo multiplication by division. So we end up with x is equal to 28 divided by 24. X is equal to, and let's see, 28 divided by 24 can be reduced. I think there's a common factor there of 4. So when I divide 4 into 24, I'm going to get 6. When I divide 4 into 28, I'm going to get 7. And that's how I'm left with the final answer, 7 over 6. All right? One last comment that I want to make here before we call this problem quits. Be careful before you just start punching your final answers into calculators and giving me answers as decimals, because a lot of times when you start doing things on a calculator, what you're getting is an approximate answer, not an exact answer. And unless your instructor says that they want an approximate answer, in general, those calculators can be deadly because you're not giving an exact answer to the problem. So my recommendation in general is to stick to fractional form unless your directions state otherwise.